Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning to all the participants today and those who are follow us in a Facebook Live for this webinar knowledge sharing sessions on insulation coordination bare overhead line system, right? So hopefully everyone is doing great today, right? So I believe many of us working at home now, and hopefully this pandemic will end soon and our country will achieve herd immunity 90% and above, and hopefully this pandemic will convert to endemic soon, inshallah, right? So before we continue this webinar session, if you can hear the audio and video clearly, all right, please give us some emoji so that we can know that everybody can hear and see this video clearly, all right? Okay, thank you very much. All right, for the participants that give emoji thumbs up, all right, smilings, thank you for your feedback, all right? So what is today webinar all about, right? So today is a collaboration between TNB, CIRED, and ACEM knowledge sharing sessions webinar series. So today's topic is a very interesting topic, which is insulation coordination for bare overhead line systems. And our speaker, IRTS Cik Muhammad Faris, will explain more about the basic principle of insulation coordination, especially in MV bare overhead lines in distribution network TNB and protective device for insulation system, right? So take your seat. Our speaker will explain more details about it, all right? Okay, before we start with our webinar sessions, I hope all the participants can register in the Google form for attending this webinar session, right? So please scan this QR code and go direct to the attendance link from your, okay, for your information also, right? Those who are registered in this webinar session will receive electronic certificate. Yes, you will receive electronic certificates with these webinar sessions. And another good news is you will also eligible for 1 CPD hours, right? So please make sure the name filled in correctly with your full name as per in IC, because of the certificate will be issued according to the names that you are entered into the Google registration form, right? Okay, I will repeat again because of this is a very important things you need to take attention, right? So please make sure the name you are filled in correctly, right? With your full name in the IC, right? Because of the certificate will be issued according to the names that you are entered in the Google Classroom, in the Google registration form, right? So please tell to your friends, your colleagues to join this webinar session because we will start very soon, okay? So can we have some few minutes more to ensure all of you can fill in the attendance form, right? Please fill in the full name as per IC, all right? Your email address, okay. Please make sure also this email address fill in correctly because of the email address will be sent to your email that you are registered in the Google registration, right? So third one is a phone number and positions and company names, okay? For those who have successfully completed this attendance form, can you share the emoji to us, right? Anyone finish this completed attendance form, right? Can you share some emoji? Okay, that's good, right? I see many participants who have successfully complete this attendance form. That's good, right? Okay, thank you very much. Okay, all right. So we would like to have some engagement sessions with all of you guys today, right? So we want to know all of you guys, what is your background, right? And how you found us today, right? So hopefully all of you can join in this Slido and you can use your laptop, either your phones, all right? Firstly, you need to scan the QR code or you can type slido.com in any browsers then type overhead, and the passcode is TNB, a small letter. Okay, so we give some 1 minute for all of you to join in these Slido sessions. So for your information, in the last session, we will have some quiz, right? And the quiz also we use like this Slido, right? So you need to familiarize with this Slido because we will use it again in the end of the sessions. Because we have some quiz and feedback sessions, right? Hopefully everyone can participate these engagement sessions. Any participant who just joined this webinar sessions, okay, you can start, scan the QR code in the screen type and then type slido.com. You can type overhead and passcode is a TNB, small letter, right? Okay, can we proceed with the first questions in the engagement session, all right? Okay, how are you today? All right, we want to know how are you guys today? You can comment and click send. All right, so okay, that's good. All right, excited, yes. Feeling well, that's good, right? Sehat, alhamdulillah. Alhamdulillah, great. Okay, best. Okay, that's the one I'm looking for. Best. Okay, that's good, right? So awesome, that's good, right? So all the best. Okay, hebat. Okay, that's good, awesome. All right. Okay, so hopefully everyone is doing good, great today. All right. So please take care, everyone, and ensure all the SOP are followed. Right. Okay. Thank you very much for your feedback. All right. Okay. Some more. All right. Some response. All right. That's good. Okay. Can we go to the next? Okay. Are you a CIRED members? Okay. We want to know, all right? Okay. So many of us is not a CIRED member. Okay. 89%, 90%. Okay. A lot of us is not a CIRED member. So don't worry, guys. All right. I will explain to you what is a CIRED, all right? And how to register in this CIRED and what are the benefits to get the membership of a CIRED, all right? So can we move to the next questions, all right? Are you aware of the existence of the CIRED Malaysia? Okay, before you can join CIRED, we want to know that are you aware on the existence of the CIRED Malaysia? Okay, that's good to hear that. Majority. I think majority, most of us know the existing of CIRED Malaysia. Okay, that's good, all right? So let's go to the next question, right? So which industry are you attached with, all right? We want to know, are you from TNB itself? Are you from telecommunications, from academic peoples, right? Oil and gas and other industry, right? Okay. 68 majority is from TNB, okay. But second majority is other industry, okay, that's good. Okay, from academics, wow, 14% from academics. Oil and gas, wow, 3%, okay. And other utilities is 3%. That's good. So we have multiples of industries join us in these webinar sessions. Okay, that's good, guys. Okay, can we move to the next question, right? Where do you get this webinar information, all right? So we want to know where you get this information. Is that by email? Is that by message or WhatsApp or Telegrams? Or from your friend itself, from a CIRED, IEM, and the others, all right? Okay. Oh, majority is from email and message, WhatsApp, Telegram. 42%, 42%. Okay, that's great, guys. All right. Thank you for all of you for sharing this webinar session to all of your friends. Okay. So let's move to the next question. All right. So in a one word, all right, what do you expect from these webinar sessions? Okay. Or other words is, what do you want from these webinar sessions? Okay, you can type any free text and you can send to respond, right? knowledge. Okay, new technology. Yes, we have some introduction of new technology in this webinar. All right, knowledge, of course. We will share some knowledge and informations. Okay, enlightenment. Yes, of course. All right, pengetahuan baru. Of course, kita akan terangkan berkaitan dengan teknologi dan juga pengetahuan yang berkaitan dengan tajuk kita pada pagi ini. Okay, new info and knowledge. Yes, okay. Motivation. Okay, I think we need to put on some motivation inside our webinar. All right. So, okay, thank you. Most of us, the content is aligned with what you want to know today, this webinar. Okay. So, all right. So, can we move on to the next slide? All right. Thank you very much for your response. Okay. Okay, before I explain about the CIRED membership, okay, firstly, we need to know what is CIRED, okay? So CIRED is abbreviations for Congress International de Réseaux Électriques de Distribution, all right? It is a French word, right? So Pertubuhan CIRED Malaysia, it is also headed by our Chief Distribution Network Officer, which is CDNO, TNB, which is Encik Wan Nazmi bin Wan Mahmud. All right. CIRED Malaysia have committee from the member from TNB itself, from academic and manufacture side. All right. So what are the benefits of CIRED membership? Okay. The first one, the member will be updated with a new technology and latest technical knowledge in a power distribution industries. Right? The member will aware of the current practice framework with respect to the Malaysia electricity supply industry, or we call as a MESI 2.0. All right? So member from the local industry or manufacturer or supplier are well informed on the needs and requirements of the MESI 2.0, Malaysia electricity supply industry. All right? So the fourth one, members are encouraged and give a platform to have an open discussion on issue pertaining to MESI 2.0, especially dialogue between utilities and energy-related industry. Okay, guys? In general, all right? In general of a CIRED, it is a platform to you guys to get all the technical knowledge and to get involved in the MESI 2.0 discussion, all right? So how do you become a member of CIRED Malaysia, okay? The first one, you need to fill in the forms in the CIRED, or you can log in into the website Malaysia, you can fill in the form, all right? So second one, you need to pay one-time entrance fee, which is RM 200 ringgit, and then the annual subscription fee, which is RM 100 ringgit, okay? That's as simple as that to get the CIRED membership. Okay, guys? Okay. For your information, all right, TNB had collaboration between CIRED Malaysia and ACEM to organize a various topic of webinar series. Okay, guys? As per today, we have 11 topic of webinar series open to all the CIRED members. Most of the webinar series is a monthly basis. Every month we have a webinar series. Okay, we have this CIRED knowledge sharing session. Okay, we have started this webinar series since July 2021. Now we are on the fourth topic of CIRED knowledge sharing webinar with the topic installation coordination for bare overhead line systems. All right, so this webinar will be continue every month, guys, until the next year, 2022, all right? So, okay, without further ado, all right, let me introduce myself, okay? I will be a moderator for this webinar today. Okay, my name is Muhammad Fazli bin Nozlan. I'm Senior Engineer, Technical Expert Support, Overhead System Design and Diagnostic from Engineering Services Asset Management Department, all right? I have a 14 years service experience in TNB. I started from 2007 in TNB Johor 33 kV, and then I started from 2017 until now, I'm in engineering services. Okay, guys, let me introduce you our presenter today. Our presenter today is a IRTS Cik Muhammad Faris bin Arifin. He is a specialist overhead lines, system design and diagnostic from engineering services, asset management department, distribution network, TNB. He has a vast experience, 30 years experience in TNB. Started on 1991 to 1994 as a transmission line and substations. 1994 to 1999 in shift control operation and RCC, and then experience in distribution operation SCADA, telecontrol, distribution zone network manager, network services, and 2003 until now, IRTS Encik Muhammad Faris is in engineering services as specialist overhead line design system and diagnostic. Alright, he has completed his education in Bachelor Science in Engineering Northern Arizona, USA, and he also completed a Master of Electrical Engineering in UNITEN. Alright, so IRTS Cik Muhammad Faris is a professional engineer with practicing certificate from BEM. He also a professional technologist, EE from MBOT. He also a CIRED Malaysia Secretary, right? ITC Level 1 Certified Thermographer, SDT Level 1 Certified Airborne Ultrasound Inspector. He also certified drone pilot SUAS by Civil Aviation Authority Malaysia, CAM. And he also a TNB competent person up to 275 kilovolt and TNB authorized person up to 132 kilovolt, right? Okay, before I hand over this session to IRTS Cik Muhammad Faris, I need to highlight some rules, guys. Okay, number one, all right, all the participants will be muted throughout the presentations, okay? And number two, all the questions shall be asked through the Q&A tools, okay? Number three, the chat will turn off when speaker giving the presentation because we don't want any of you guys in the chat box while the presentation sessions, right? So, but we are enabled the Q&A tools, so all your questions can be asked in the Q&A tools, all right? So, and lastly, please pay the attention all the time because of we will have a quiz at the end of the sessions and there will be a prize for a winner, okay? So without further delay, okay, I will invite IRTS Encik Muhammad Faris for the presentation sessions, okay? IRTS Encik Muhammad Faris, the floor is yours, okay?
Assalamualaikum and very good morning to you, ladies and gentlemen. Thank you for joining us this morning for a webinar series, TNB-CIRED and ACEM webinar series. And today's topic will be distribution network installation coordination practices on 33 kV bare overhead line system in TNB. I'll be talking on the knowledge sharing. I'm not going to teach you on the academic side. It is the a presentation based on the perspective of a practitioner. Okay, as we are here in TNB, we are the practitioner. Okay, I'm not going to bore you with all the calculation, with all the formulas and all that, but more on the what we are doing or practicing in TNB currently. Okay, the structure of our knowledge sharing today will be I'll be introducing some of the aspect of insulation coordination. What is insulation coordination? And then I'll be talking on the types of medium voltage overhead lines in TNB. And then what will be the requirement, minimum requirement for pole footing resistance or tower footing resistance? And what is the motivation for the enhanced lightning performance that we need for our medium voltage overhead lines? And After that, I'll be talking on the installation coordination best practices currently in TNB. And moving on, I'll be talking on the installation coordination strategy in TNB using new technology, because we have to tackle two main challenges. And our main focus will be to improve on the worst performing feeders. I'll be talking on the new advancement in TNB installation coordination with the use of long arc flashover arrestor, which is a new technology in installation coordination for distribution network in TNB. Okay, ladies and gentlemen, what is installation coordination? All right. A definition by IEEE saying that installation coordination is the selection of installation strength consistent with expected overvoltages to obtain an acceptable risk of failures. And we also have IEC's 671 definition, the selection of dielectric strength of equipment in relation to voltages which can appear on systems for which the equipment is intended, and taking into account the service environment and the characteristics of available protective devices. So basically, ladies and gentlemen, installation coordination is to select the installation strength. For example, for 33 kV, the installation strength can be up to 170 kV, right? And protective devices that can include surge arresters, Franklin rod, arcing horns, right? And for an installation system such that the protective level of the installation is always below the withstand level of the device to be protected with a safe margin. And in TNB, the safe margin can be between 25 to 30% margin. And the focus for this knowledge sharing today will be on the distribution medium voltage bare overhead line system, because we also have substation installation coordination. But I'm not I won't be talking about substation, because my area of expertise is on the distribution medium voltage overhead lines. So in other words, because we have a mouthful of definition from IEEE, from IEC, to put it simply, we want to ensure electrical strength of installations and associated devices are correlated to match system characteristics and expected range of voltages. And what are the expected range of voltages? It can be lightning over voltage, switching over voltage, transient over voltage or TAV, highest system voltage, and MCOV, or the minimum continuous operating voltage. It can also be said that installation coordination is to reduce the probability of installation failure and supply interruptions caused by installation breakdown to an acceptable level, both operationally and economically. Okay, so the key here is we allow installation breakdown, but to an acceptable level in order to protect the system. And installation coordination is achieved, yes, by altering the dielectric withstand or using suitably graded surge arresters to protect the equipment. So those are some of the simple wording in terms of the definition given by IEEE and also IEC. Okay, so we are good here. So far, so good. All right. So in TNB, we need to know the types of medium voltage overhead line system and where can we apply this installation coordination. All right. In TNB, we have two types of medium voltage overhead lines consisting of two major systems. First, we have the bare overhead line system, as shown in the pictures on the left, and also the aerial bundle cable system, the picture on the right. Our focus today will be the bare overhead line system. Usually, the focus will be on the bare overhead line system because it is more susceptible to lightning-related interruptions. It is usually situated in rural areas, and the bare medium voltage overhead lines are facing aging issues because most of them commissioned before the year 2000. For the bare medium voltage overhead lines, it can be categorized into two major systems. First, we have the shielded system. Okay, the shielded system is on the left. Okay, the shielded system has steel cross arm with 13.5 meter steel pole and with an overhead shield wire at 45-degree angle for protection against direct lightning strike. Okay, we have the shield wire up here at a 45-degree angle. And secondly, we have the unshielded system made up of 13.5 steel pole also, but with wooden cross arm. It does not have any shield wire, but with an increased BIL or basic insulation level with the use of wooden cross arm at 300 kV per meter and having an arc quenching properties. Okay, so we have this wooden cross arm. It is having a higher BIL as compared to the 33 kV system with a minimum requirement of 170 kV, and the wooden cross arm has an arc quenching properties. And then we also have the shielded bare overhead line system on P2 steel pole, as shown here on the left here, and an unshielded bare medium voltage overhead line on a P2 steel pole also with wooden cross arm, and without any overhead, without overhead shield wire. But the design is still having an angle of 45 degree for protection against direct lightning strike. Okay, the most important aspect in installation coordination is the earning minimum requirements and configuration, because we need to ensure that the lightning current can be dissipated to ground effectively. Okay, a minimum pole footing resistance or tower footing resistance is required to ensure that the lightning discharge can be effectively dissipated to ground. Poor pole footing resistance or tower footing resistance can cause bad flashover to the bare medium voltage overhead line. Figure 1 illustrates how PFR or TFR affects the effectiveness in reducing bad flashover incidences on bare medium voltage overhead lines. So, as you can see from the graph, right, the less the ground resistance, the less the flashover per 100 kilometer per year. So that is why we need to keep the ground resistance as low as possible. And in order to ensure that the lightning current can be effectively discharged and dissipated to ground without causing bad flashover to the bare medium voltage overhead lines, TNB adopts the following PFR or TFR requirements as best practices, as shown in Table 1. Okay, for example, poles with equipment such as automatic circuit reclosers, load break switches, isolated links, surge arresters, the minimum requirement for the PFR would be 3 ohms. Shielded bare overhead line with steel cross arm, 10 ohms. And the unshielded bare overhead line with wooden cross arm, the minimum measurement should be 15 ohms. All right. Ideally, of course, we want the TFR to be 0 ohms, but that would be impractical and maybe not economically viable. Okay, so our goal for having this minimum requirement for PFR and TFR will be to achieve the lowest ground resistance possible that makes sense economically and physically, right? So we have a few references. For example, the National Fire Protection Agency and IEEE recommending 5 ohms or less for telecommunications industry, 5 ohms or less for the earning measurement. NEC 250.56, 25 ohms or less, but facilities with sensitive equipment should be 5 ohms or less. And for IEEE standard 1410 recommends that for any CFO less than 200 kV, the TFR or PFR should be 10 ohms, and the CFO at 300 kV to 350 kV, the TFR should be less than 40 ohms. All right. So the minimum requirement for earthing is as shown on the screen. Okay. For example, if you have a homogeneous soil, so the minimum requirement is that this is considered the helicopter view. You have the pole, and this is the first rod, 1 meter away from the pole, and another copper rod with the counterpoise earth tape at 5 meter apart. Okay. But what if we have a low-high soil, meaning that the top layer having a low resistivity, but the bottom layer having high resistivity. So the configuration would be from the pole, we have 1 meter, distant from the first copper rod, another 5 meter to the next copper rod, and we lay the counterpoise earth tape 10 meters from the second point, right? But without any copper rod driven into the ground because the top layer is already having low resistivity. And for high-low soil, the top layer having high resistivity and the bottom layer having low resistivity. So the configuration is a bit different, where we have 1 meter counterpoise tape, and then we drive the copper rod to the ground, and then another 5 meters spacing, another copper rod, and another spacing of 5 meter. We have another copper rod. So this would be the three minimum requirement for pole footing resistance and tower footing resistance configuration. So if you look from the helicopter view, if you have a low-high soil where the top layer having low resistivity and the bottom layer having high resistivity, so this would be the configuration, the full configuration for a pole, right? And this would be for the high-low soil. So this earthing rod configuration would improve on the earthing requirement for each pole. All right. The probable causes for minimum voltage overhead line failures due to lightning can be due to bad flashovers, shielding failures, and induced overvoltage, right? And IEEE 1410 recommendations to mitigate medium voltage overhead line failures due to lightning can be using shield wires, increase the insulation, install the line surge arrestor, and improve on the footing resistance. Okay. But for the recommendations made by IEEE standard 1410 to be effective, the tower footing resistance or the ground resistance must be low, because the installation of shield wire, increased insulation level, and installation of line arrestor can be effective only with the TFR set to a very low measurement or value. Okay, so that will be a challenge for us. And when we talk about the grounding or the earthing, we have to also look into the frequency domain, because the behavior of grounding, when we look through the eyes or through frequency domain is actually different. The behavior can be different. For example, if we inject 1 amp to a mesh, right, using 0 hertz, 50 hertz and all, 500 hertz, 50,000 hertz, 500,000 hertz, the behavior will be different. For example, from 0 to 50 hertz, the display or the configuration or the the behavior of the grounding will be sort of like a quite uniform, right? You have a very uniform ground potential rise, or the rise of earth potential would be quite uniform. But what happens if we inject 1 amp at 5 kilohertz? So you can see the behavior is beginning to be different. It is concentrated at where the injection or the current injection is being made. It is more focused on that area or that mesh, right? And also when we do some analysis in frequency domain, the earth potential of a small grid at 60 Hertz seems to be having a uniform rise of earth potential. But the earth potential over the small grid at 50 kilohertz is a bit different. Well, not a bit different, it's different, right? So you can see that it is concentrated at where the the injection of current is being done. So the peak is where you have the current being injected to the ground. And at 1 megahertz is even different. So at fault current, maybe the rise of earth potential will be uniform, okay, at different points. But if you have lightning over voltage, due to because lightning over voltage can occur during at a very high frequency, so the earth potential or the rise of earth potential will be different, right? So this is something that we have to bear in mind. Okay, so what is the motivation for having an enhanced lightning performance? Why do we care a lot about our installation, right? In Malaysia, for example, okay, we don't have any choice, right? Having a nominal BIL and PFR or TFR requirements may not be enough, as Malaysia sits in the equatorial region where the ground flash density, or GDFD, is one of the highest in the world. As illustrated in figure 2, the average GFD in Malaysia is between 30 to 40 flashes per kilometer squared per year. It's one of the highest in the world, okay? So we have no choice. We have to do a lot to protect our band medium voltage overhead lines. Okay, some simple risk analysis. Okay, what happens if we don't do anything? We don't do insulation coordination, for example. Okay, once the lightning strike and hit the line conductor, and assuming that the surge impedance of the line conductor is at 300 amps, okay, and once it hit, okay, typically the lightning impulse in Malaysia is at 20 kA, so it will split into two waves, one going to the left and one going to the right. So at 10 kA, okay. So having a surge impedance of 300 ohms and a lightning current of 10 kA, the potential rise can be as high as 3 megavolts. That is very high compared to our 33 kV system, having only at 170 kV basic insulation level. Okay, only that, although the lightning wave, lightning current wave can travel through our conductor, it is maybe traveling up to 1 to 2 kilometers only. Still, still we need to protect. Before it attenuates, it will do a lot of damage to our overhead lines. Okay, so what is the strategy? Okay, first we need to deviate the lightning strike. How can we do that? Because we won't be able to ask the lightning to hit places that we want the lightning to hit, right? We are not God, right? So what we can do is we try to avoid direct lightning strike to the conductor. Use of overhead ground wire to shield the conductor from the lightning. Okay, so in that way, the the lightning will not hit directly on the conductor. We insulate. Why do we need to insulate? We insulate the installation of the medium voltage overhead line from flashover or back flashover, due to overvoltage. And as I've said earlier, the overvoltage can be anything from lightning, switching, TOV, maximum system voltage, and of course we need to also consider the minimum continuous operating voltage when we want to insulate any electrical installation. Then we need to dissipate the lightning current. Why? To provide an effective path for lightning current to dissipate so that the protective voltage of the system will be below the BIL. For example, if we have a 170 kV BIL for our 33 kV system with a margin of 25%, for example, so we need to reduce the protective level, the voltage or the residual voltage, to maybe around 150 to 170 60, right? 140 to 150, between 25% to 30% protective level or safe margin. Okay, and with all the deviation, insulation, and dissipation, okay, DID, we need to coordinate, right? DID to be well coordinated so that failures of the middle voltage overhead lines are at an acceptable rate, okay, as per the definition of IEEE and IEC, right? Instead of having permanent faults due to loss of insulation, causing longer insulation or interruption, the insulation coordinations allow transient interruption to protect the system, but with shorter interruptions and faster restoration of supply. So it allows some acceptable rate of interruption, but not a permanent interruption or permanent fault, but we allow transient interruption at a very shorter time duration, and we have faster restoration of supply. Okay, so there will be two kind of over voltage due to lightning. One is direct lightning strike, and another one is indirect lightning strike, or the induced over voltage, right? So direct lightning strike can occur or can happen to our poles or towers, and phase conductors will be the most dangerous, and of course the overhead shielding wire. For the direct lightning strike, causing induced over voltage, it can be due to lightning hitting the trees, buildings nearby, telecom towers, or other power line towers near the vicinity of our distribution overhead lines. Okay, and why do we need to really protect our system from direct lightning strike or even indirect lightning strike? For example, with direct lightning strike, it will cause lightning impulse. Indirect lightning strike can cause lightning induced over voltage. Both can cause flashover to the system, and because of the flashover, it will develop into fault current, and our protective system, our relays, for example, will see that as a fault, and due to that, there will be system interruption, and then that will cause supply to be disrupted. The supply to our customers will be disrupted. So we really need to look into this lightning performance to ensure that we minimize the system interruption or the interruption of supply to our customers. Okay, so before I continue, we take a break and I hand over the session to our moderator. Thank you.
All right, thank you very much, IRT Encik Muhammad Faris, for the first part of the presentation. Okay, we will have a 5-minute short break, guys. All right, any question, please use Q&A tools. We will come back to you guys, all of your questions in the last session. Okay, so after this, all right, some video about ACEM, which is Associations of Consulting Engineer Malaysia, will be presented to all of you guys. All right. So for those who want to know more about ACEM, please stay tuned, all right? See this video presentation. Okay.
For more than 5 decades, ACEM's been focused on advancing professionalism and affecting change, because that matters to you as a professional, a consulting engineer. Regulations, status, influence and command. The Association of Consulting Engineers Malaysia, ACEM, has looked out for you through many milestones passed by our nation. Our quest started way back in 1963. Now we're headquartered in Kuala Lumpur with branch offices in Kuching and Kota Kinabalu. Come join us and be counted. Our goal is about empowering, looking into your interests, rights, and privileges, availing a platform for your voice to be heard with the government, public bodies, and industry associations, as well as extend cooperation with related bodies and stakeholders. When it comes to being a member of the Association of Consulting Engineers Malaysia, ACEM, it's about being involved and keeping abreast with our profession. From a membership spanning sole proprietors and partners of engineering consulting practices, ACEM is the reference point and influencing factor, driving matters that affect consulting engineers in our country. With 900 individual members and 470 member firms, representing in excess of 20,000 employees, ACEM has the clout to become a formidable partner to be aligned with. We're heard in over 90 committees and work groups, and that includes ministries and local governments, government agencies, and related associations. ACEM's reach also ensures a voice in regional and international matters as well. Advancement of the consulting engineering profession is the essence of ACEM's existence. Working through standing committees and the Secretariat, ACEM continually provides a platform and paves the way, affecting and courting change. Our track record spans more than 50 years as a sole catalyst, augmenting the role of the consultant engineer. There have been many. The delivery of the Manual Perolehan Perkhidmatan Perunding 2011, which instruments the upward adjustment of government-approved salary scale. It was us. QBS as a government procurement policy. That was us too. Ad valorem stamp duty on construction agreements and BEM ruling on stamp duty. ACEM's insignia was clearly there too. And what about the future? Our relevance was also captured in the Green Building Index, GBI, for Malaysia. We believe in addressing what is needed. At ACEM, we believe that the consulting engineering profession grows in stride with ongoing global developments. We lead the torch in facing hurdles and charting the way towards a more efficient and effective profession. Because with ACEM, not one of our professionals gets left behind. Like a flame that never dies, ACEM is hard at work, overseeing and monitoring the landscape. Quite often, we're prompted to anticipate concerns and initiate engagement, like the implementation of the REA 2015, which allows liberalization of the industry, push for complete liberalization of consulting practice, urge for regulations requiring local participation in FDIs, promoting green initiatives in the built environment for waste reduction, resource conservation, sustainability of ecosystem, and improvement of quality of human life. Safeguarding fair and equitable treatment to all stakeholders involved in the construction industry, and encouraging technology adoption for the efficiency, productivity, and advancement of the construction industry. ACEM, for the betterment of future generations. Your participation is our advancement.
Okay, ladies and gentlemen, right? Hopefully the video is smooth, all right? So that you can know more about ACEM, all right? Association of Consulting Engineer Malaysia, all right? Okay, guys, before I pass back to IRTS Muhammad Faris, I would like to recap again what we have learned in the first part of the presentation, all right? So the first, we have learned about the definition of insulation coordination, how to select insulation withstand strength such as 33 kV system is using 170 kV, all right? And then we learned about two types of MV bare overhead lines, which is number one is called as shield, all right? And number two is called unshielded. Because of shielded is the overhead lines bare integrated with the earth wire on the top of the lines, all right? And the system is using a steel cross arm, right? So unshielded is without earth wire on the top, right? And the system is used wooden crossarm. Okay, we also learned about TFR, all right? TFR is a tower footing resistance with three conditions of TFR. Okay, number one, the TFR for equipment must be 3 ohms and below, right? Number two, TFR for shielded systems, it is a 10 ohm and below, right? Number three, TFR for unshielded, it is a 15 ohms and below, all right? We also learned about the lightning and lightning impulse at 20 kA and potential rise can up to 3 megavolt, right? Okay, next. Okay, some housekeeping rules. Okay, some housekeeping rules, housekeeping announcement, sorry. Okay, I would like to remind again for those who are not filled the attendance form, okay, please do it so, okay. You can scan this QR code or go direct to the link attendance form, all right. Please make sure your name is filled in correctly with your full name as in the IC. Because of this certificate will be issued, all right, according to the names that you are entered in the Google registration form. Okay, you need to fill up your names, a full name as an IC, email address, a phone number, position, and company names. All right. For your information, for those who are registered in this webinar session, you will be received a certificate and will be eligible for 1 CPD hours. Okay. Okay, second housekeeping announcement, all right? How to become a member of CIRED, right? First, you must fill up the forms. You can log in to the website CIRED Malaysia, which is https://www.cired.my, right? And then second, you need to pay one-time entrance fee, which is RM200 and annual subscription fee, it is RM100. As simple as that, all right? Okay, guys, we would like to start with the second presentations, right? Without further delay, I will invite IRTS Cik Muhammad Faris for the second part of the presentations. IRTS Cik Muhammad Faris, the floor is yours.
Okay, ladies and gentlemen, welcome back. For those of you who have joined the WebEx session, and also for those who have joined the FB Live. Okay, so continuing on, now I'll be talking on the installation coordination best practices in TNB. Before that, please excuse us because maybe the the speech is not so clear because we have to wear the mask, and sometimes I have to take a pause because I need to get the oxygen, my oxygen supply, right, so that I can think what I thought. All right. So now I'll be talking about the installation coordination best practices in TNB. Okay. All right. Various approaches have been adapted to enhance the lightning performance of the bare medium voltage overhead line system based on various studies to improve on the lightning protection approaches and early enhancement management that had been carried out with TNB Research and University Tenaga Nasional, or Unit 10, as follows. First, we have TNB Research study on lightning performance improvement of the 30 kV Tanjung Batu to Rompin overhead distribution line in 2008. Then we have a joint collaborative study between TNB Research and Unit 10 on insulation coordination practices guideline for bare medium voltage overhead line in TNB distribution system in 2009. So we have this guideline. This is the cover of the guideline that we published in October 2009 for the use of our engineers, planners, and also technicians, right? And thirdly, we have TNB Research study on earthing and lightning performance improvement of the 11 kV Tampa to Gopeng overhead distribution line in 2011. So we have done a lot of study to improve on the installation coordination in TNB. Why? Because of the GFD level in Malaysia is so high, right? Okay, before I continue, let me introduce to you the notion or the definition of CFO, critical flashover voltage, and BIL, the basic insulation level. Okay, CFO or critical flashover voltage is used to describe the insulation strength of overhead lines. Okay, and CFO voltages refer to the 50% probability of insulation failure when impulse shaped with CFO peak voltage being applied to the insulation. So it has the probability of 50% failure. And CFO normally used for self-restoring insulation. Why is that? For bare minimum voltage overhead line, we call it CFO instead of BIL, because the main insulation for our bare minimum voltage overhead line is air. So air is self-restoring insulation, right? But we also have solid insulation, where the solid insulation is also known as non-self-restoring insulation, and this is what we use when we talk about basic impulse or basic insulation level. So the solid insulation would include glass disc insulator, porcelain, for example, or even composite material, right? So we also have solid insulation plus the air as the main insulation for overhead lines. So that's why we need to coordinate between the air insulation and solid insulation. Okay. The first best practice that we have been using so far is the use of wooden cross arm with additional 300 kV per meter, CFO, with arc quenching features. Okay. As a best practice, wooden cross arm with a BIL of more than 300 kV per meter is installed at high lightning activity areas with poor grounding or areas where improving the soil resistivity is difficult, challenging, or requiring high operational expenditure and having few or no natural shielding. When we talk about natural shielding, it can be high structures, it can be trees, for example, or even other power system or poles, such as transmission line towers, right? With the use of wooden cross arm, okay, the BIL of the bare minimum voltage is increased up to 300 kV per meter as compared to the nominal 170 kV BIL requirement for 33 kV overhead line system. Moreover, the wooden cross arm is capable to quench the arc caused by the lightning over voltage. So in the picture here, we have wooden cross arm being used. Okay, the nominal BIL for our glass disc insulator will be 170 kV, but with the use of wooden cross arm, okay, we can add up another 300 kV per meter of insulation, right? So from here, we know that we have 170 kV plus another 300, maybe 330 kV, right? At this area here. And then we have a more higher insulation at the outermost conductor here, 170 kV plus 2.8 meter, so maybe around 700 kV, an additional 700 kV, and another, for example, this conductor here, 170 kV plus another 330, so we have around 400 kV of insulation. Okay. And some of the pictures are showing the use of wooden cross arm in TNB system. Okay. Mainly it is being used in northern part of the peninsula, even in the eastern region, and some in the southern region. Secondly, we have the use of earth enhancement compound to maintain good power footing resistance or tower footing resistance. Currently, the use of earth enhancement compound based on risk analysis is focused on poles with equipment, such as automatic circuit closers or load break switches, and those poles installed with such arresters to avoid damages on the equipment due to high lightning impulse and to mitigate accelerated aging of the surge arresters. So we have here from the pictures how we lay the counterpoise copper tape in the trenches. We install the copper rod, and we have to make sure that the counterpoise earth tape are being joined using exothermic joint. And lastly, we will spread the earth enhancement compound on the copper tape before we put back the soil on top of it. Okay. And this will be the simplest form of deviation, or we want to deviate, right? Deviate the lightning strike so it does not strike the conductor, right? So the use of franking rods on unshielded medium voltage overhead line in order to prolong the optimal service life of distribution class surge arresters placed on selected overhead lines poles or towers by diverting the lightning current directly to ground, such that by doing so will reduce the magnitude of lightning impulse that needs to be discharged by the surge arresters to ground. Okay, so we try to divert or deviate, like the first part I was talking about. We want to deviate the lightning surge so that it will go to ground without causing the surge arrestor to do overtime work, so that we can ensure that the surge arrestor can have a nominal service life, right? And the combination of the 1 meter rod and also the use of wooden cross arm at a high tower footing resistance area can eliminate, or not to say eliminate, can minimize the effect of lightning impulse on our system. Right. And moving on, number 4, we use and maintain the arcing horns at 42 cm across glassless insulator string. Okay, a lot of questions came by or being directed to us. Why 42 centimeters? Why not 50? Why not 30? Why not? Why even install the arcing horns? Okay, when it only does this causing transient tripping, right? So by maintaining the arcing horn gap at less than 42 cm, the critical flashover voltage across the gap will be set at 165 kV, allowing flashover to manifest across the arcing horns due to voltage breakdown of air in order to protect the glass disc insulator string. So we have to look back at the definition, acceptable failure rate. So we allow the air to break down. So we have the air insulation and the solid insulation of the glass disc insulator. So what happened here is that we allow the insulation breakdown of air, right, to protect the glass disc insulator. Instead of having a permanent interruption of our overhead line, we allow transient interruption at a very short period of time and with fast restoration. It will be cumbersome, or it will be detrimental if we allow the glass insulator to be damaged due to the high impulse, because that will cause permanent interruption to our system, causing a longer duration of power outage to our customer. So this is how coordination works. We allow breakdown on the air in order to protect the solid insulation of the overhead line system. Okay, so we have this formula, the critical flashover voltage, okay, with a striking distance S in meter, and then we have kg, where kg is the gap factor. When it is during dry condition, we use 1.0, and during wet condition, we use 0.96. And typically, the BIL for our 33 kV is 170 kV. So that's why we set at 42 cm or below, because we want the gap to have a flashover or a CFO at 175 kV to allow that flashover to occur across the gap, across the arcing horn gap, to protect the glass face insulator. So that is very important. We are trying to deviate from permanent interruption to transient interruption at a very short period of time and fast restoration. Okay, and like I've said before, when the lightning strike on or close to the line, it will cause overvoltage on the line, and because of that, there will be flashover of insulation. Okay, so the use of arcing horn, where we have the gap across the arcing horn, the air will be ionized, causing flashover to conduct across the gap. But with this flashover of insulation, it will cause follow current or a short circuit, and the protection, our protection relay will see it as an earth fault. So the automatic circuit recloser will trip to quench the follow current, and the recloser will be set to reclose at 10 seconds. The ACL, the automatic circuit recloser can trip for the second time if a restrike occurs across the gap. So it will reclose another 20 seconds, okay, from the dead time to the reclaim time. But however, with poor earthing, it can cause back flashover. Okay, so with the use of surge arrestor at high frequency, surge arrestor conducts 10 kA of lightning current to earth until the residual voltage drops below the BIL. Okay, at a very high frequency, the impedance of the surge arrestor will become very low, causing the surge arrestor to conduct discharging 10 kA to ground. If you can see the formula, when the frequency becomes very, very high, okay, the impedance will become very low, close to zero. So it will be seen as a short circuit. And that's why the 10 kA can be conducted down to ground. Okay, but with the use of surge arrestor, the automatic circuit recloser will not detect any earth fault, as the discharge to earth will occur at a very fast rate in the range of microseconds. However, again, poor earthing can cause accelerated edging on the surge arrestor. Okay, so now we talk about the surge arresters. Okay, right. So there is a non-linear voltage and to current relationship of the surge arrestor. For example, during normal operating zone or the minimum continuous operating voltage, the surge arrestor will not do anything, will not conduct. Okay, but when it comes to switching protection level or lightning protection level, it will become it will start to conduct, and this will be the protection zone. Okay, right. The use of 10 kA distribution class surge arresters expedites the discharge of lightning current to ground to reduce the lightning over voltage, such that the residual voltage produced will be below the BIL of 33 kV of line components and equipment. Okay, so if we can see this diagram here, we have system voltage continuous, we have the TOB, temporary over voltage, we have the switching over voltage, and we have the lightning over voltage. Lightning over voltage can be more than 5 U0. For example, if we take a simple calculation, this can be up to 180 kV, but that is already more than the BIL of components, because for 33 kV, the BIL of our components will be about at 170 kV, right? So it is more than the lightning over voltage will be more than the BIL of the component. So when we install the surge arrestor, it will limit the lightning current or the lightning over voltage below the BIL of the components, and it will give a protective level of about 25% to 30%. Okay, and from this graph, optimized placement of surge arrestor as per IEEE 1410, if we can put one surge arrestor every 3 span, we can minimize the effect of lightning over voltage. But then if we don't put any arrestor, the flashover per 100 km per year will definitely increase. Okay, so between 1 to 3, it is acceptable in terms of flashover per 100 km per year. Okay, so for example, if the lightning strike, you have the lightning wave higher than the BIL. Okay, so once the surge arrestor start to discharge 10 kA, okay, the product will be a shock wave or a residual voltage which is below the BIL of the components. So this voltage will be kept low to protect the installation of associated equipment, for example, auto recloser, what you call that, load rate switch, or even isolated links. Okay. And as per IEEE 1410, installing such arresters at every pole can virtually eliminate flashover due to lightning over voltage, but that is techno-economically not practical. One of the goals of insertion coordination is to reduce flashover rate to an acceptable risk of failures, both operationally and economically. And strategically, the optimal placement of such arrestor are as follows. 1, at poles on high ground flash density or high lightning incidences, at poles on hilltop or highest point, at poles ascending or descending hills or highest point, at poles with high pole footing resistant or tower footing resistant. Only that placing such arrestor on poles with high PFR or TFR can result in accelerated aging of the such arrestor, and at every post or every 2 poles at locations mentioned above. So we put either every pole or every 2 span, right? At the location mentioned in A, B, C, and D. Okay. Then next, the use of 10 kA gapless MOV surge arrestor class 2 now is known as station low or SL for 33 kV medium voltage overhead line, and class 1 or now known as distribution high for 11 kV medium voltage overhead line. Why? Because these two will ensure that the arrestor has the nominal energy absorption level for it to function effectively while discharging the lightning current to ground, and that the surge arrestor will not become damaged while doing so, especially when you have multiple lightning strike at the same spot. So it has to work over time, right? It has to discharge so many times before the core of the lightning arrestor or the surge arrestor will become hot, right? So if it is not unable to absorb that kind of energy, it will damage the surge arrestor. So we have to have a higher energy absorption level with the system we have in Malaysia. Why? Again, because we have the highest GFT, one of the highest GFT in the world. Okay. Now, I'd like to talk about the new advancement of installation coordination practice in TNB. Okay, we go back to our strategy. We deviate, we insulate, we dissipate, and we need to coordinate all the DIDs, right? Okay, here's an idea. Can we dissipate the lightning current to the air? By doing so, we don't need a good earthing value or earthing measurement, right? So by discharging or dissipating the lightning current to air, and air can quench the arc of the lightning current, so we don't really need the the minimum requirement of this earthing, right? So is that possible? The challenges in installation coordination in TNB is to tackle 2 main things. First of all, areas with high lightning activities, okay, and secondly, areas with high soil resistivity resulting in poor PFR or TFR. Okay, and our main focus is to improve on the worst performing feeders. The focus to mitigate lightning interruptions is prioritized based on the worst performing feeders, in terms of number of interruptions caused by lightning, right? And TNB has classified WPF in terms of number of interruptions indicated by the table below. Okay. Current lightning protection installed on TNB medium voltage overhead lines includes metal oxide resistor line surge arrestor class 2, or now is called station low, as per the IEEE 1410 guide for improving the lightning performance of electric power overhead distribution lines. However, the earthing system, high resistance, and the high soil resistivity values can affect the line surge arrestor service life. Moreover, other lightning protection devices such as Franklin rods, overhead shield wire, require good earthing to avoid back flashover to the bare medium voltage overhead line system. For the case of the MOV line surge arrestor, earthing system with low resistance helps in improving the line lightning performance and ensuring the MOV line surge arrestor operates according to its intended lifetime. High earthing system resistance area with more than 15 ohms PFR or TFR may cause the installed MOV line surge arrestor to age prematurely and hence increase maintenance costs. So now we are going to introduce the line lightning protection device, okay, or LLPD. The use of LLPD using the long arc flashover arrestor without the use of MOV is a proven solution for improving line lightning performance for poles located in areas with high soil resistivity values and high density or frequency of lightning activities. Okay. The long arc flashover arrestor or LFA working principle is shown on the screen. A lightning over voltage wave travels along the line will arc across the LLPD gap, and the arc will be quenched through the air as illustrated via the discharge band. So we have a discharge band and the arc will be quenched across the LLPD gap. And the LLPD gap is about 115 mm or 11.5 centimeter as opposed to the 42 centimeter arcing horn, right? But because of the arc quenching is done over the air, not through, we don't need to discharge it to ground, and because of that, there will the protection relays will not see an earth fall when this happens. So good earthing values are not required. So can it be done, right? So I'm going to show you how the long arc flashover arrestor quench the lightning current on the system. I hope you can see the video. So the lightning current will be discharged and quenched through the on the air across the gap. Okay. Okay, a case study conducted by TNB Research Neighborhood for TNB distribution network on a line running through a high lightning incident area with high pole footing resistance located in Perak, having selected for this LFA technology assessment project. Okay, the line in question is the Prah Langkat 30 kV overhead line. The study line configuration includes both the shielded bare medium voltage overhead line and unshielded bare medium voltage overhead line. For the shielded bare medium voltage overhead line, it uses a steel mass lattice structure with overhead shield wire. Okay, this is the picture here. Okay, and while the unshielded bare medium voltage overhead line uses tubular steel poles with wooden cross arm, as shown in the picture here. Okay, so this is the Prah Langkat line. Right? In order to determine the suitability of the case study line of the LLPD applications, the PFR or TFR and soil resistivity values were measured. Sample poles and lattice mass that are located at considerably high soil resistivity area, where we have the top or middle layer more than 200 ohms meter, and earthing resistance values of more than 15 ohms were chosen. Okay, because we want to prove the hypothesis that the LLPD works on an area with high lightning density and at a high earthing resistant value. Okay. And then the second part will be to monitor the lightning activities along the Prah Langkap overhead line between June to December 2016. And the highest lightning activities within 5 km radius of Prah Langkap overhead line were recorded. And in November 2016, as per table shown and as shown graphically using the TNB LDSN lightning map. So all the dots represent lightning strike near the line. And we can see that in November 2016, it recorded the highest number of lightning activities near the line. You can see the line here. Okay, so this is the line. So we have a lot of lightning activities near the 5 km radius of the line. And as a result, it has been observed that a reduction of 93.6% transient interruptions rate due to lightning, okay, had been achieved after the installation of the LLPD on the bare medium voltage overhead line, where conventional methods is unable to do so effectively at high soil resistivity area and high pole earthing resistance of this line due to failure caused by accelerated aging of the MOV line surge arrestor and back flashovers. Okay. Secondly, we found out that with the use of the LLPD, it has reduced transient interruptions related to lightning and hence has improved CIRED. Moreover, the LLPD technology saw a possible long-term and efficient solution for the 32 kV medium voltage overhead lines against direct lightning strikes. It also helps to reduce replacement costs of the MOV line surge arrestor damages due to their premature aging on bare medium voltage overhead lines located at areas with high resistivity, and costs for earth enhancement management has also been identified based on economic analysis of this initiative. Okay, so as a conclusion, the major criteria for LLPD installations are as follows. The bare medium voltage overhead line is identified as a worst performing feeder due to frequent transient interruptions or lightning-related failure due to high-density lightning activities. The bare medium voltage overhead line runs through high-frequency lightning incidences, as confirmed by the TNB Research Lightning Detection System Network lightning map. Thirdly, the bare medium voltage overhead line having poles, mass lattice structures, or mini lattice towers being erected on high grounds, on mountainous or hilly areas that are susceptible to lightning strike or having historical failures due to lightning strikes. And lastly, the bare medium voltage overhead line sits on high grounds or being erected on high soil resistivity area due to rocky or sandy soil where mitigation with earth enhancement is not viable. And before we can use the LLPD, there are certain step-by-step process to determine the suitability of installing the LLPD, and it is recommended to ensure that the LLPD techno-economic effectiveness. Okay, for the first 3 months or action tier 1, we identify the WPF and verify it with the lightning data from the end research. The next 3 months or action tier 2, we assess. Assessment would be evaluation of the line performance in terms of the pole footing resistance, and also the study to optimize the placement of the LLPD. And the next 6 months or action tier 3 is to install and monitor. To implement the field installation of LLPD at optimized location identified based on the criteria specified before, and to carry out continuous monitoring on the feeder performance after installation of LLPD with the use of auto recruiter data and lightning data. Okay, and some modification that we have made, although good grounding is not required for the LLPD to function, the LLPD needs to be connected to the earth mass. So as such, a modification needs to be added to the overall design of the LLPD to ensure that the LLPD is connected to the earth mass. Okay, so to ensure that this requirement is met, especially for poles with wooden cross arms, instead of installing the LLP across the overhead line with threaded string as shown in Figure A, the LLPD is installed on additional brackets, okay, directly to the steel structure of the pole as shown in Figure B, or steel towers of the or steel lattice of the mini tower as shown in Figure C. Excuse me. And to expedite the rollout in utilizing the LLPD nationwide, okay, the followings have been formalized and completed. First, we have the TNB technical specification for the LLPD, and we have the line lightning protection device standard operating procedure. Excuse me. Okay, and training has been done and completed by October 2020. Okay, so we have to have all this to expedite the rollout in TNB, what you call it, use. And what's next? So to end my presentation, the installation coordination strategy in TNB is still ongoing. Okay, we still have a lot of work to do. Although the medium voltage overhead line, the bare medium voltage overhead line in TNB is not that long. I mean, we have only about 4,000 kilometers, and we are migrating with the construction of medium voltage arrow bundle cable system in order to to mitigate issues of transient, issues of lightning strike and all that. Okay, but the current existing overhead lines, bare medium voltage overhead lines, is still needs to be taken care of, right? So we still have a TNBR study on feasibility study and technologies for in-service line such as health conditions monitoring in distribution network. Okay, so the line search register would be the main protective device for ensuring that we minimize or mitigate the lightning interruptions for TNB medium voltage overhead lines. So we need to ensure that the search registers are in a good condition, or always in a good condition. And secondly, we have a unit study on impact of induced overvoltage on distribution overhead line performance. We have a lot of distribution line sitting next to transmission lines. So we want to study whether there is any induced overvoltage issue. And if there is, what can we do to minimize the induced overvoltage issues in distribution overhead line performance? And thirdly, a proof of concept of the lightning protection device monitoring system. Okay, ladies and gentlemen, that is all from me. I hand over the session to IRTS Muhammad Fazli for the next session. Thank you very much for your attention.
All right. Okay, thank you so much. All right, thank you so much, Cik Faris, for the second part of the presentations, right? So next, we will go to the Q&A session, okay? Sorry. Okay, so we will go to the Q&A session. All right, okay. So again, I will check the Q&A session from all of you guys. So, okay, IRTS Cik Muhammad Faris, there's some few questions from the participants. So I already answered some questions in a Q&A tools box, right? Okay, so let's go to the first question, right? Sir, how about area with prone to lightning? What are the best methods to prevent lightning interrupt? From Mr. Muhammad Najib.
Okay, for those areas having a high density of lightning density activities, for example, and I think the best way is we can use IEEE 1410 recommendation, where we can install surge arresters at every 1 or 2 span. Okay, but we have to make sure also that the soil resistivity or the pole footing resistance is meeting the minimum requirement. But if we have a system with high lightning activities, but with poor soil resistivity or pole footing resistance, we can mitigate or even minimize the effect of lightning current with the use of LLPD or the line lightning protection device. Okay, I hope that answers your question.
Okay, thank you very much, Mr. Cik Muhammad Faris. Okay, we go to the second question from Mr. James. All right, I see there will be a less lightning protection for shielded systems as for unshielded. How does it works? I missed out the part earlier, all right?
Okay, you mean in terms of a shielded system? Okay, shielded system, we for the shielded system, okay, we have the overhead ground wire. Okay, that is one. Okay, we go back to the deviate, insulate, and dissipate, right? And then we have to coordinate these three DIDs, right? So for the unshielded system, okay, we need to deviate. We need to ensure that the lightning does not hit our conductor, right? Because if it hits the conductor, it will do a lot of damage to our medium voltage overhead lines. So we need to use this what we call that, make sure that the earth wire is properly installed. Secondly, right, we need to insulate. Okay, we insulate it at 100. We have to make sure that the 170 kV minimum requirement is met. Okay, and if so, we have to also make sure, because we have the solid insulation and the air insulation, we have to make sure that the arcing horn is also properly installed at 42 cm minimum gap, so that we allow the flashover to occur across the gap. Okay, so that we mitigate the interruption of the overhead line from permanent interruption, causing longer this loss of supply to our customer, to transient tripping, where it is only occurring momentarily within seconds, and we can restore the supply in terms of very fast restoration within 10 seconds, for example. And we have to also put or install line arresters, okay, line surge arresters or surge arresters. And for 33 kV, we recommend that you use distribution class 2, or now we call it a station low, right? Because of the high energy absorption level. It can absorb more energy from the lightning current, okay, and it can dissipate or discharge the lightning current to ground. Because we are finding that there are also multiple strikes on a single or on the same line. So if the multiple strikes occur on the line, the surge arrestor will have to work overtime. It has to discharge so many times within 1 minute, for example. So it has to have a robust build, and in terms of energy absorption, it needs to be able to absorb, discharge within that 1 minute or 3 minutes, right? And lastly, very important, ensure that the pole footing resistance meet the requirement. For example, if you have the automatic circuit closer, load break switches or isolated link, it has to be less than 3 ohms. For unshielded, make sure that the pole footing resistance is below 10 ohms. And if you cannot achieve that, use the earth enhancement compound. That will help to reduce the PFR or the FR of your line. Okay, so I hope that answers your question.
Okay, thank you, Cik Muhammad Faris. So next, we go to the next question from Mr. James. Another question, is arcing horn only used on a glass insulator? How about porcelain insulator? We always experience nuisance trippings, which we suspect due to the arcing horn. Do you have a similar experience?
Okay, similarly, we can put the arcing horn and ensuring that the gap is 40 cm for both the glass and also for the porcelain insulator. However, there is an issue with porcelain insulator. For example, if there is the impulse is too high, the glass insulator will rupture. It will sort of like, you know, rupture, and it will be blown to pieces. Okay, but for porcelain, mechanically, porcelain is higher in terms of strength, but electrically it's not as good as glass insulator. And because of this, when this occur, when there is a damage on the porcelain insulator, you have what you call it, these micro cracks. Okay, and these micro cracks cannot be seen with the naked eye. And for example, if you have these micro cracks in the porcelain insulator, there will be issues of, you know, the dielectric strength of the porcelain insulator is already deteriorating. So you won't be able to see all these micro cracks because it is internally. So that is why we prefer to use glass insulator, because if there is if the dielectric is already over the strength, it will rupture. Yeah? Okay, that is simple for us to detect. But for porcelain, it is very hard for us to detect the micro cracks. And then, for example, when it is in wet condition, the water will seep into the micro cracks, causing a direct path from the live conductor to the earth. It develops into leakage current, but as the leakage current develops, okay, it will become a fault. So that will cause the transient tripping. But when the transient tripping occur at very high current, right, or high voltage level, the water will dry. So that's why when you read those, okay, the tripping will be clear. Okay, because the water inside the porcelain will be dry. Okay, so that is the nuisance that I can think of why we migrate from using porcelain and then we migrate to glass pieces later. Okay, I hope that answers your question.
Okay, thank you, Encik Muhammad Faris. So I think hopefully that will answer your questions. And then one more thing, you need to be precautions about the maximum gaps of arcing horn, Encik Faris, correct?
Yes.
So that must be careful, because of if you are using a system 33 kV, you must ensure the maximum gaps between the arcing horn is 42 cm. Yeah. Hopefully that you cannot ensure that it is lesser than 42 cm, and it also can causes you a transient, right? So let's go to the next question. All right, I think the fourth question already, right, from Mr. Razak. What will happen if TFR, tower footing resistance, is higher than requirement? Is there any possibility that transient can be happen because of the higher TFR? Right?
Okay. Yes. Due to the poor TFR or PFR, the lightning current cannot be effectively dissipated to ground. What will happen? It will go back. You know, it will cause a back flashover. All right. So lightning hit the shield wire, for example, and it will travel across along the steel structure of the pole or the tower, and it will need to be dissipated to ground. But what if the tower footing resistance or pole footing resistance is not good enough to dissipate the lightning current? It will go up again through the the steel structure, and it will try to hit the weak points, and the weak points will be the arcing horns, all right, or even the insulator string, right? So that will cause a back flashover and causing the line to trip because of the back flashover, okay, develop into fault current, and it is seen by our protective relay as a fault. Then that would cause the system to interrupt. That is why we need to really look into the tower footing resistance and pole footing resistance to avoid back flashover. Okay.
All right. Okay. Hope can answer your question. All right. So we go to the next question, all right? From Mr. Billy, all right? What is a minimum earthing resistance in ohm required for 33 kV?
Minimum ohms required for 33 kV.
Yes, the question.
Okay, the tau footing resistance.
Yes, tau footing resistance.
Okay, so for the 33 kV, okay, it's also similar because we have the shielded and unshielded, and also poles with equipment. So poles with equipment, we need to ensure that the tower footing resistance or pole footing resistance is less than 3 ohms. For shielded system, it needs to be below 10 ohms. Okay, and for unshielded with the use of wooden cross arm, for example, we have to ensure that the pole footing resistance or tower footing resistance is below 15 ohms. And again, it is what you call it. It is a requirement. Okay, and if you find that you have a very high pole footing resistance or tower footing resistance, it can be improved with the use of earth enhancement compound. Earth enhancement compound actually made of bentonite, okay, to improve on the performance of the earthing, right? But we need to use counterpoise earth tape, okay, copper tape, and also copper rod to ensure that the dissipation of lightning surge or lightning current to ground is effective. Okay, I hope that answered the question.
Okay, thank you, Cik Muhammad Faris. All right, so I think we have many come up questions, all right, lately, all right? So I think we take the last questions, okay, from you guys. So don't worry, we will answer all of your questions in a FAQ and upload this later, all right? So for the last questions from Encik Ahmad Rizwan, yeah, all right. Sir, how good is earth mesh system in preventing a back flashover, right? As in the slide shown, earthing for footing is an X formations.
Okay, thank you for the question. It's a very good question, actually. Okay, the mesh system. Okay, you have to look the performance of the earthing for lightning using frequency domain. I've shown you earlier that the performance of frequency domain is very important to analyze the grounding of the system. For example, if you have a power frequency failure or a power frequency interruption at 50 hertz, okay, the ground potential rise on a mesh system, the ground potential rise will rise uniformly. Okay, that is detrimental or very important to avoid step voltage. Okay, but for high impulse lightning issues, right, we need to discharge or dissipate the lightning current as fast as possible. And when you look at the frequency domain, the reaction of the ground, okay, at the place where the lightning is being dissipated, the ground potential rise is very high. It's very, very high at that point of time. So instead of using mesh, we use the counterpoise tape, okay, with the X formation, so that at the four corners, it can dissipate the discharge the lightning current to ground as soon as possible, because the ground potential rise is very high. So it needs to be discharged very, very fast to the ground. Unlike using the mesh, okay, even if you have the mesh also, it will not go throughout the mesh. It will only concentrate on where the lightning current is being injected to the ground. Okay, so I hope that answers your question, because for substation, for lines, we don't really use a mesh because it is more for the step step voltage management. Okay, for fault on what you call that, this at 50 hertz or at power frequency. but for lightning purpose, it is at high frequency, so the behavior is different actually. So that's why we have the X or the four corner earthing system for our poles. I hope I answered that question.
Okay, thank you, ILT Encik Muhammad Faris, for answering all the questions. All right, okay, guys, we have a time constraint with the other sessions. All right, I will stop the Q&A session for now. Thank you for all your questions. All right, we really appreciate it. Right, so we will answer all of your questions in FAQ and upload this later to you guys. All right, okay, now we will move to the next sessions. The next sessions will be a feedbacks and a quiz sessions. Okay. Okay, let's move on to the feedback and the quiz sessions. Okay, hopefully guys, you can join on the Slido. I think it is quite familiar to you guys. Right, you can use your laptop or you can use your phones to join the Slido. Firstly, again, I repeat again, you need to scan the QR code, or you can type slido.com, all right, in any browsers, all right, and then type overhead, all right, and the passcode is a TNB. Okay, so I believe everyone already familiar with the Slido, right? Because of we already tried before in beginning of the session. So hopefully everybody can join this Slido session for feedbacks. Okay, so after these feedbacks, it will continue with the quiz, all right? Like I mentioned before, all right? So there will be a prize for the winner. Okay, so let me start with the feedback for the first question, right? So timeline for this webinar, is that too short? Is that too long or adequate time, right? So we need a response from all of you guys for this timeline for this webinar. Okay, 35 people already answered, right? Already respond, right? So how about others? Okay, almost 40 people, 40 participants, 41, all right, already respond. Thank you very much for your response, right? We are waiting because of the numbers keep increasing, right? Okay. Okay, all right, 45 people already, all right? So we move to the next questions. The presentations by the panel was effective and easy to understand, all right? So you can give a feedback to us, okay? Evaluate our presentations by our presenter, all right? You can choose it. Okay, thank you very much. 46 already feedback to us, all right? So we go to the next questions. I understand the content of this webinar, all right? So please evaluate the contents so that we are present today, all right? Okay, I believe that the content has been reached to you guys and you guys understand it, right? So let's go to the next questions. I'm interested in participating in the upcoming series of webinar organized by TNB or CIRED, right? So you can answer it, very interested, neutral, not interested, and very not interested, right? Okay, next, right? We're moving to the next questions. Okay, join the quiz. Okay, so thank you very much for all your feedbacks. Okay, we really appreciate it so much. All right. Next part, we will have a quiz, all right? So to join the quiz, put all your names and be ready for the quiz, all right? For your information, the winner for this quiz session will be given a special prize. Hopefully that you can ready for the answer of all the questions, right? So we have already 37, almost 40 participants who are joined in this quiz sessions, okay? So hopefully this number will increase, right? So we are waiting with others. For those who are just joined in these sessions, okay, you can scan the QR code, all right? And then you can join us at slido.com and type overhead, and the passcode is a TNB, all right? So almost 50 people who have joined this webinar quiz, all right? Okay. I think 1002855 is a staff TNB, right? TNB staff for sure, right? All right, okay. Okay, all right. Are you ready, guys, for the quiz? Right? So get ready with your phone or your laptop, all right, to answer the question, all right? Okay. Let's start the quiz, all right? Ready? 1, 2, 3. Okay. What types of MV bear overhead lines in TNB? All right. MV bear overhead lines in TNB. You must read the question carefully, right? Okay, another 1 more seconds. Okay, time's up. All right. So most of you answered shielded and unshielded system, all right? So let's see the answer. Yes, correct. Most of you correct. Answer it, all right? Okay, let's see the leaderboard. All right. Okay, congratulations to Melati, Filarius, Mr. Wong Sihu, Billy Low, all right, and Prashant, all right? Okay, congratulations, all right, for the first question, okay? So let's move on the second question. Okay, what is the minimum requirement of TFR? TFR is a tower footing resistance for pole with equipment on MV bare overhead lines in TNB, all right? So what is a minimum requirement of TFR for pole with equipment, all right? Okay, time's up, all right? Majority answered lesser equals to 3 ohm. Okay, let's see the answer. Yes, you are correct. All right, it is a lesser equals to 3 ohms. Okay, so let's see the leaderboard. Right, leaderboard. Wow. Okay, Mr. Billy is now ranking number 1. Next is Kamsa. Next is Hakim. And 700410 Hakim Samsul. All right, okay, that's good. All right, let's move on the third question, right? What is the minimum requirement of TFR, tower footing resistance, for shielded systems on MV bare overhead lines in TNB? All right, just now is on pole with equipment. This situation is on shielded system. What is the minimum requirement of tower footing resistance? All right, so time's up. All right, majority answer is lesser equals than 10 ohm. Okay, let's see. Yes, you're correct. It is a lesser equal than 10 ohms. Okay, let's see the leaderboard. All right, so Mr. Billy is leading now, number 1, and next is Mr. Shahrin. All right. And number 3 is 10028553. Number 4 is MO. Wow. MO. Okay. Number 5 is Mr. Hakim. All right. So let's go to the next question. All right. Question number 4. What is the minimum requirement of TFR, tower footing resistance, for unshielded system on MV bare overhead line in TNB? All right. The keyword is unshielded, guys, right? The first one is equipment, second one is shielded, and this question is unshielded. Okay. Okay, that's good, right? So 66% answered lesser equal 50 ohm. That's correct, all right? So we see the leaderboard, all right? Leaderboard, still ranking number 1 is Mr. Billy, and shortly is a Mr. MO, ranking number 2. Wow. Okay, and then continue with 10028553 TNB staff, all right? Number 4, Mr. Hakim. Number 5 is Mr. Shahrin, all right? Okay, let's go to the next question. Question number 5. What insulation coordination practices being used in TNB? Okay, using a wooden cross arm, franking rod, earth enhancing compound, surge arrestor, arcing horn, or all of the above. Okay, all right. So what is insulation coordination practices? All right. So just now, IRTL Cik Muhammad Faris already explained it. Yeah. So many things that part of insulation coordination practices using in TNB. All right. Most of us, 84% answer correctly. All right. All of above, yes. Of course, we are using a wooden cross arm. We are using a franking rod. We are using earth enhancing compound and surge arrestor and the arcing horn. All right. Okay. Let's see the leaderboard. Right. Still ranking number 1 is Mr. Billy, Mr. MO, TNB staff. All right. Mr. Shahrin and Mr. Hakim. All right. So top 5. All right. Okay, next, we go to the next question. Question number 6. What is minimum striking distance across the arcing horn gaps? All right. That's, I'm telling you, the arcing horn, there is a minimum striking distance. All right. What is the minimum striking distance? Okay, please read the answer carefully because there is a mm and there is a cm. Okay, all right. So that's why I'm telling you, right? Okay, there is a mm, there is a cm. You must be careful about that. All right. So 45% answer 42 cm. All right, that's correct. Okay. So another 22% will answer 42 mm. I think you are slightly wrong because of the units, right? Okay. So let's see the leaderboard. All right. Oh, that's good. Still good. Still great. Mr. Billy still on the top. All right. And second, Mr. MO. TNB staff. Where TNB staff? All right. Okay. Number 3, Mr. Shahrin. Number 4, Shah. And number 5, Mr. Samsul APP Pahang. Okay, that's great. All right. Okay. Next. Question number 7. What is BIL? All right. What is BIL? Okay, is that basic insulation level used for non-self-restorating insulations, or basic impulse lightning, or below impedance level, or all of the above? All right. So you must read it carefully. All right. So what is BIL? Okay, time's up. All right. Let's see. Okay, majority answer is a basic insulation level, BIL, used for non-self-restoring insulations. Okay, that's correct. All right. Okay, let's see the ranking. All right. Oh, congratulations, Mr. MO. Now you are ranking number 1. All right. So next is Mr. Shahrin and Mr. Shah, Mr. Yus, and then Mr. Billy in the ranking number 5. All right. Okay, let's go to the next question. Question number 8, all right? So, what is CFO, all right? Just now, the question is about BIL. Now, the question is about what is CFO, all right? What is referred to, all right? Okay, you have another 5 more seconds, okay? Please read it carefully. Okay, right. Okay, majority answers is a number 2, which is referred to 50% probability of insulation failure when impulse wave shaped with CFO, peak voltage being applied to the insulation, all right? So it is a normal trick, right? If the answer, there is a long answer, so you think that that is the answer, the right answer, right? So actually the answer is all of above, right? So CFO is a critical flashover voltage, right? It also describes the insulation strength of overhead lines, right? So it also refers to 50% probability of insulation failure, right? So it also refers to use for its self-restoring insulation. And it refers to the air. Air is also self-restoring insulation. And the answer is all of above. Okay, let's see the leaderboard, right? So, okay, that's good. Mr. MO is still standing at ranking number 1, right? And continue with Mr. Shahrin. And third, Mr. Billy, Mr. Shah, and Mr. Yus, right? Okay, let's go to the question number 9. Okay, where is the best placement for surge arrestor in MV bare overhead lines? Except, alright, you must remember, except, kecuali. Please read it carefully, alright? You have another 3 more seconds. Okay. Alright, so there's a various of answering this question, alright? So most of you answer at every 3 span at per IEEE 1410, alright? Okay, the answer is at pole with a low GFD. GFD is a ground flash density, alright? So normally when we want to place the surge arrestor, normally we put at the higher GFD, alright? So that is accept virtually at the pole with a lower GFD, right? Okay, so let's see the leaderboard, right? So still standing, right? Okay, that's good, Mr. MO. And then number 2, Mr. Billy. Wow, all right. Increase from number 3 to number 2. That's good, all right. Number 3, wow, Mr. Sam. All right. Number 4, Sharin. Number 5, Mr. Hakim. All right, that's good, all right. Okay, let's go to the last question of the quiz. Like I mentioned before, all right. Top 3. The winner for this quiz will be given a special prize for you guys, all right. So the last question, all right. So, okay, where is the best placement for LLPD, line lightning protection device in MV bare overhead lines, except, okay, kecuali, right? So must read it very carefully, all right? So kecuali, right? Okay, time's up, all right? Let's see. Okay. 66% answer at the pole with a low tower footing resistance. Okay, that's good, right? Alright, because of LLPD, the best placement, one of the best placement for LLPD is we need to put at the higher tower footing resistance because of it quench on the air. Alright, so that's good, guys. Alright, so that is 10 question for this quiz today. All right, so I think we have a winner. Let's see the winner after this. All right, guys. All right. Okay, all right. Congratulations to Mr. MO, Mr. Billy Lau Tiao Jian, and Mr. Sam. All right. Okay, these 3 winner, please check into our chat box, all right? Write in your name and your phone number, all right? We will send to you the prize, all right? So please send your names and your phone number in the chat box, all right? The 3 winner, all right? Congratulations for the